You have seen it happen. A single suspicious file lands in your environment, and suddenly you are not dealing with one problem anymore. You are dealing with a family of problems. Copies, variants, droppers, loaders, different delivery paths, and a trail of related activity that stretches across endpoints, email, web gateways, and cloud services. The hard part is not just detecting something bad. The hard part is understanding what it is, what it does, what it is connected to, and how quickly you can turn that understanding into a confident response. That is where you start thinking beyond individual investigations and toward a capability. The ability to explore, analyze, and correlate malware at scale without your team drowning in repetitive manual work. Azul exists for that exact gap, and it is designed for malware investigators, incident responders, analysts, and cyber teams in large organizations and government agencies. Once you move from occasional investigations to constant pressure, your analysis approach often collapses under its own weight. People start saving samples on shared drives with inconsistent naming. Evidence gets spread across tickets, chat threads, and spreadsheets. Analysts duplicate work because nobody can easily see what was already learned from similar samples. Leadership asks a simple question like, is this related to last month's incident? And the honest answer becomes, maybe, but it will take time to prove. At scale, the goal is not just to store files. The goal is to store knowledge about files, preserve context, and make it searchable and reusable. Azul helps uplift malware analysis capability by enabling collaboration, quickly identifying common malware behaviors, and improving the speed and precision of response activities. Before you fall in love with any tool, you need to understand its boundaries. Azul is a malware repository and analysis platform focused on archiving, analytics, and clustering so you can handle very large volumes of suspicious or malicious files over time. But Azul does not decide whether a file is malicious. You do not feed it unknown files and ask it to label them good or bad. Anything stored in Azul should already be identified as suspicious or malicious through binary triage tools, incident response activities, threat hunting, or honeypots. That distinction matters for leaders because it tells you how to place Azul in your incident response architecture. It is not your first gate. It is your knowledge engine after suspicion is established. Now that you understand the boundary, you can appreciate the purpose. Manual reverse engineering is expensive. It can take hours to extract basic indicators of compromise, days to understand capabilities, and months to truly map a malware family. Azul was created to improve the productivity of reverse engineers by letting common analysis steps become automated plugins and workflows, so you do not repeat the same manual effort for every variant. This is not just a technical improvement, it is an operating model improvement. You are converting human insight into repeatable automation, and that is how you scale. With that foundation set, you can frame Azul in 3 capabilities that matter in real response conditions. First, Azul acts as storage for malware and suspicious files, helping analysts share malicious files safely. Second, it performs automated malware analysis, including things like sandbox execution, configuration extraction, and file carving. Third, it supports correlation of malware samples that share similar functionality or command and control information. When you put those together, you get something powerful. A structured place where samples, analysis outputs, and relationships between samples can be explored in one environment, rather than scattered across tools and people. Now you can zoom in on the repository capability. A classic failure in incident response is losing context. You might still have a copy of a file, but you cannot confidently answer where it came from, which hostname first saw it, what the original file name was, what network segment it touched, and what time window mattered most. Azul tracks origin information provided during upload, and that information is configurable. It can include host names, file names, network information, timestamps, and other contextual information. Files are stored in a simple storage service compatible object storage system, and Azul is designed to be highly scalable, intended to store tens of millions of samples for all time. In leadership terms, that means you are building a long memory system rather than analyzing malware in isolated incidents. Once you have the repository, the next question is how you extract consistent insight from what you store. Azul provides a framework for automating scripts derived from reverse engineering efforts to pull out indicators of compromise or other features, saving time on repetitive manual tasks. It supports a range of static analysis, tooling so common tasks like decompression, handling common Microsoft Office formats, applying Yara rules, using snort signatures, and similar steps can be repeated reliably. The real multiplier appears over time. As plugins are improved and updated, analysis can be repeated on historical artifacts, generating new insights into past incidents. This is a governance advantage because when you learn something new today, you can apply it to yesterday's samples and discover relationship you missed at the time. Once analysis produces structured features, correlation becomes possible. Azul supports clustering and search-driven correlation to help you find commonalities between samples so you can determine shared upstream infrastructure, patterns of development, and other links that indicate a shared campaign. When you add industry reporting and your internal telemetry into the way you interpret those clusters, you stop thinking in terms of this file and start thinking in terms of this campaign. Campaign thinking is what leadership needs because it reveals intent, persistence, and risk trajectory. Now translate at scale into operational reality. At scale means tens of thousands of suspicious attachments from phishing surges, continuous streams of dropped payloads from endpoint detections, and opportunistic scanning malware that lands repeatedly across your internet-facing estate. Azul is built to handle very large collections of samples and is designed to scale, which means you can treat it as part of your long-term capability rather than a short-term incident tool. It is not built for one reverse engineer's laptop workflow. It is built for organizational use where multiple teams need shared visibility. During an incident, user experience is not cosmetic. If analysts cannot quickly pivot, search, compare, and explain, your response slows down and confidence collapses. Azul provides a web-based analyst interface for quick access, including in-browser searchable hex and strings views. It includes built-in views for detailed tool outputs such as decompilation, system call logs, detected capabilities, and raw file structure and layout. It also shows extracted features and which plugins produce them, which helps triage and manual reverse engineering decisions remain fast and defensible. If you store malware at scale, you must control access and prevent misuse. Azul is designed to safely share, store, and retrieve malware, and it includes granular security markings to control visibility and access for sensitive samples. That matters because some samples may contain sensitive victim data, embedded credentials, or information about your environment. Just as important, Azul is designed to integrate into existing user authentication, processing workflows, and automation pipelines so you avoid creating yet another security island that teams abandon. When it fits into identity and workflow patterns, adoption becomes realistic rather than aspirational. Now bring it to life with a realistic scenario. Imagine a phishing campaign hits your finance teams with malicious attachments disguised as invoices. Your email security catches some, endpoints catch others, and a few reach user inboxes. Some users click, macros run, and an initial loader drops a second stage payload. In this scenario, you do not just have one artifact. You have multiple artifacts. attachment variants, dropped loader variants, and second stage payload variants. If you only analyze one, you might miss how the campaign evolves over days. With Azul, once files are already flagged as suspicious through triage processes, you ingest them with preserved origin context, run automated analysis to extract consistent features, and then correlate the samples to see which ones share infrastructure, behavior, or command and control patterns. Instead of chasing alerts, you build a campaign view that supports faster containment and cleaner executive reporting. Now think about ransomware, because it is where incident response maturity gets exposed. Ransomware incidents often start with credential theft, remote access abuse, lateral movement, and deliberate disabling of security controls. Encryption is the final act, not the first. If your teams only analyze the final encryptor sample, you miss the ecosystem. Loaders, credential stealers, discovery tooling, persistence mechanisms, and staging artifacts. Azul's strength is storing and correlating many samples over time so you can identify relationships and reuse analysis logic when variants appear again. For leadership, this changes your post-incident posture. You stop asking, how do we clean up this one event? And start asking, what patterns do we now recognize? And where do we break the chain earlier next time? Now step back and treat Azul as more than a tool. It is a malware knowledge base designed for archiving, analytics, and clustering, created to improve productivity and reduce repeated manual reanalysis. That means you can build an internal knowledge base that strengthens over time because your stored history grows, your plugins improve, and your correlations become richer. This is one of the rare security capabilities where more history improves resilience rather than becoming dead data, because it supports learning, detection improvements, and repeatable understanding. Now place Azul cleanly into an incident response operating model. You treat your triage layer as the gatekeeper. Email security, endpoint detection, sandboxing, threat hunting, and honeypots decide what is suspicious. Azul sits behind that gate as the knowledge and correlation layer. It stores suspicious files, automates deeper analysis, and connects samples into clusters and campaigns. In executive terms, Azul becomes a force multiplier for incident response and threat intelligence by improving speed, precision, and defensible evidence, especially when you are operating under pressure and scale. Leadership needs proof, so you need the right measures. The most meaningful measures are not how many files were stored. You measure whether response and understanding improved. You look for reduced time to extract indicators of compromise, reduced duplication of analysis across teams, faster ability to confirm whether a new sample relates to a known malware family, and improve confidence in incident scoping because correlations are easier to prove. Over time, you also look for stronger detection logic and fewer repeat incidents because you keep learning from history rather than losing it. Open source tools like Azul support knowledge sharing and improved analytical practices, which strengthens resilience against evolving threats. But knowledge sharing does not mean uncontrolled sharing of sensitive samples. Azul's access controls and security markings support safe handling and controlled visibility, which is the practical way to collaborate in complex environments while still respecting confidentiality, regulation, and internal trust boundaries. This is where the leadership message lands. Azul is not about making one analyst faster. It is about making your organization smarter and more consistent. When you turn reverse engineering knowledge into reusable plugins, you reduce dependence on individual heroes. When you store context consistently, you reduce confusion under pressure. When you correlate at scale, you reduce blind spots and improve strategic threat understanding. Azul helps you move from incident by incident firefighting to a durable, repeatable capability that gets stronger as your organization learns. Let's now discuss the key takeaways from what you learned so far. so you can carry this into your own security strategy. You have learned that Azul is a malware repository and analysis platform designed to help you explore, analyze, and correlate malware at scale. You have learned the boundary that Azul does not determine whether files are malicious, so you place it behind your triage and detection processes as the knowledge and correlation layer. You have learned that its value comes from safe storage with preserved context, automated analysis that standardizes outcomes and reduces repeated manual effort, and clustering that helps you identify shared infrastructure and behavior so you can understand campaigns rather than chasing files. And you have learned the leadership lesson. Azul is a capability builder, turning hard-won analysis into reusable organizational power. Now that you understand how Azul can change the way you investigate and respond to malware at scale, subscribe to the channel so you do not miss the next videos in this playlist. Like the video if this helped you think more clearly about incident response capability, and share it with your security leaders, architects, and incident responders who need a scalable approach. And in the comments, tell me what your biggest malware analysis challenge is right now. Volume, visibility, correlation, or speed, so I can tailor the next video to what you actually need.